So we've talked about domain before, right? That is where, I'm trying to give you a hint here. My domain is where I exist from left to the right. What are my values here? Y or X? X values, right? That's important. Super important, because we've talked about what input means. The independent variable, the domain, the X, set A. Those are things that relate to domain. So then if my input values relate to the domain, what do my output values relate to the domain, to the range? What value is that? My X or Y? It's my Y values. So where my graph goes from bottom to top. Now I want us to also remember, when we look for where a graph exists, in the domain, we see where it goes from left to right. Super important. This is where every student struggles when finding domain. You start from how far to the left it goes all the way to the right, just like a book, right? We read a book from left to right, okay? Now for the range, when we look for where a graph exists in the range, we start from how far down the graph goes to how far up the graph goes. Super important again. You have to be able to read it this way every single time. Now inequalities, we've been comfortable with inequalities, right? There are 5 symbols. Someone bold enough. What's this symbol? Read it to me in English. The one highlighted in yellow. Calliope, what do you got? Very good. This is my less than or equal. Okay, someone else for the next one, the one highlighted in blue, how would you read that in English, plain English? What do you got? Greater than or equal to. Very good. Okay. Someone else bold. What's the green one? What is it? Just less than. Okay. Someone else bold. The orange one. What do you got? Greater than. Last one. We've probably seen this before. What does that symbol mean? Bless you. Well, what do you see? Equal to. But I'm seeing a bar cutting it. So what do you think that implies? Not equal to. Very good. Very important, because we use all of these symbols for domain. So we are going to have to recall these and be able to use them. Okay, let's talk about some graph characteristics. Discrete graph, this is what we call discrete if it has just isolated points, just like this. Okay? Continuous graph is a graph of points that are connected by either a smooth line or a curve. We see this line is connected all by one straight line, smooth line, no breaks. That is what we call a continuous graph. Okay? Increasing graph. When a function increases across the entire domain. Okay, that is the technical definition. But how do we visually tell? Does anybody remember how we read graphs from left to right? Okay. Imagine yourselves, I love this example. I've been using it for years. It's just a little visual example. Imagine you were in a roller coaster and this was the roller coaster. If we read them from left to right, are you increasing or are you decreasing? Increasing, right? I'm going this way and I am increasing in the roller coaster, right? From left to right. That is how I can visually tell whether or not I'm increasing in a graph. Inversely, I go my same little cart. I'm going this direction. If you're in that roller coaster, are you increasing now or are you decreasing? Decreasing, right? If you were to be on this little roller coaster right over here, you'd see that you'd be falling down. That is how I can visually tell like this whether or not a graph increases or decreases. How do we feel? Okay, good. We still haven't done any math. We're still not going to do any math yet, okay? Constant function. This is probably one that could make sense. using the roller coaster? Let's try it. What do you notice if I'm in that little roller coaster and I'm going that direction? What am I doing? I'm going straight, right? So I'm literally just gliding in the same direction, no change or anything. That is how I know that is a constant function, right? If there's any little flat line like that, I'm constant, okay? Meaning I'm not changing, I'm not increasing or decreasing. I'm literally just staying constant in the same spot, okay? All right, function family. This is a group of functions that share certain characteristics. In this class, we're going to cover 3 big functions, right? And a lot of them derive from one parent function, right? We have just like you, right? We all have some type of parent, right? Oh, didn't spell that right. We have a parent, right? That is where the original are our originators, right? My mom and dad, right? And then from there, they have children, right? Now I'm just gonna, this is me, this is my sister, this is my brother, right? All of us together join a family, right? But my parents are the originators, right? They're where I come from, right? So whenever we see all these functions like these lines, and no matter how the line looks like, if it's all the way up or down or kind of flat, all of them derive from this. They're all in the same family. They all share the same characteristic, except we have to know where they come from. This is y is equal to x. Okay? Linear functions. So, the family of linear functions includes this form. This, everybody, is what we call the parent function. This is important. This is where every single line equation comes from. That parent function. That is the originator. That is the parent function. What's up, Clive?
I don't understand the function.
Sure. What don't you understand? How can I help?
So if the parent is y equals x, that is one function. What are the different functions that originate from?
Very good. Well, that is the originator. That is where we derive all of our all the children functions, right? All the ones that look the same, right?
What would the
Other ones look like? Okay, we could talk about, great question. We could talk about a much steeper graph, right? That would probably look something like y is equal to 2x, right? We could move the function up. Where this could be y is equal to, this would probably look like something like 2x plus 3, right? Where we're moving it up. So all of these derive from this parent function. Does that answer your question? Good. And that is how, and again, I will expose you to what each of those numbers does. But for now, I'm letting you know that no matter how the line looks like, it comes from here, our parent function. Are we okay? Okay. So, and that function that we just saw right there is what's called a linear function. That's important. I'd put a star on it. You know, what it looks like on an equation. It is a linear function. It's very important for you to make that distinction. Today you're going to look at some linear functions. You're also going to look at some exponential functions, where they look something like this. And what does that look like on a graph? Well, let's look. This would be y is equal to 1 to the x, which would look something like this. That's my parent function, right? That is where all of my functions derive from, right? And that 1 probably is a bad number, but let's just call it A. But all of my parent functions, this is what we call an exponential function. So you might be asking, Mr. Quinones, well, how am I going to remember that? I got you. Here we go. I'm going to write the word linear. I'm also going to write the word, exponential. And how I remember linear is because L reminds me of the word line. Right? Linear, line. That's how I remember it. Now exponential, I think of it like this. You see how the E is curved? Right? Like if I were to draw a bigger E, and I have the E going like this, that's how I remember it is an exponential function. Visually. So, okay, linear, I know it's a line. Exponential kind of looks like a curve when I write it, the E. That's how I remember, and you need to be able to quickly recall that information. If you see a graph, okay, that's exponential. Oh, okay, that's linear. On Friday tomorrow, we're going to talk about the last function that you will see in this class until I see you again in Algebra 2, okay? Now, there's some characteristics. We're going to talk about 2 characteristics that you should see in all the graph. X-intercept, that is where the graph crosses the x-axis, right? It's in the name. And for y-intercept, that is where the graph crosses the y-axis. That's it. Right now we're not concerned the location. We're more concerned, okay, there is an x-intercept. I see it crossing the x-axis. Oh, there's a y-intercept. I see it crossing the y-axis. That is our concern for now. Later we will calculate those values, but for now, we just want to see them, okay? Can I answer any questions? All right, here we go. So, in the last class, we talked about function notation, right? Let's consider this scenario for a moment. A shirt company charges $8 per shirt, plus a one-time charge of $15 to set up a t-shirt, right? If I were to try and create an equation, I would say, okay, my equation is y is equal to 8x plus 15, where the independent variable x represents the number of shirts ordered, right? Because that is constantly changing. So let's talk about it. We talked about independent and dependent at the beginning of our lesson, right? Or at the beginning of this unit. So let's talk about it. The number of shirts depend on the cost of the order. Doesn't make much sense, but let's flip it. The cost of the order will depend on how many shirts we purchase. Does that make more sense? Yes, it does. So depending on how many shirts that I purchase will directly impact the total cost. So that's why the shirts are the independent, and my dependent variable y represents the total cost of the order in dollars. So this, everybody, is my dependent variable. And this here is my independent. Now, in some problems, everybody, you might not see it f of x and x. You might see the variables replaced. But knowing that they play the same part in the equation is super important. For example, if I were to write it as t-shirt cost as C of S is equal to 8S plus 15, where the cost is defined by the letter C. So the cost of the shirts ordered, and the S represents the shirts ordered. I'm curious to see if you could find the domain provided, right? And I want you to see if you can find the range of this. Think about it conceptually, right? Think about how many shirts you would order and what the cost would look like, okay? I want to give you and your groups about 3 minutes for this. What is a domain? Where am I starting at? What's my first x value? My independence, okay? So I'm going to give you 3 minutes for this, if I can get this thing to work. Starting now. What is a domain? What's the lowest amount of x values that exist in this scenario? Think about it. Everybody, I'd like for you to stop at 9 shirts. I want you to write it out. I'm going to give you another 2 minutes. If I wanted to sell only 9 shirts today, what would my domain and range then be? So, I'm going to give you another 2 minutes. Think about it in context, right? Could I sell any shirts? Right? Or start 500, right? So what would be my potential starting value? 0. That's how many shirts. Okay? And then the next idea is, okay, someone bought 1 shirt, and then 2. All the way up to 9 shirts. Why am I telling you to stop? Okay, so then if I sell 0 shirts, what's the cost of that? Huh? Are you sure? If you substitute 0 here, what do you get? Are you sure? 8 times 0 is plus 15. Okay, so then when I sell 1 shirt, it would be 8 times 1 is plus 15 is 23. And then I'm going to go. Keep going with the discussions, everybody. I want to make sure everybody gets it. Oh. All right, everybody, here we go. I want you to write this exactly the way I'm going to write it too. For the domain, think about this in real world context, right? Imagine you opened up your own shop, right? And you were super excited and you open, you do your grand opening, and then nobody walks in. What's the expectation? Will anybody buy a shirt at that point? No, nobody walked in. So what could be my potential starting value then for shirts sold? 0, right? Cool. Then, okay, 1 person walks in and they bought a shirt, right? So then how many shirts have you sold? 1. Okay, do you see where I'm going? Right? I could sell 2, 3, 4 shirts, 5, 6, 7, 8, and 9. That's how I want you to write it. Okay. Now, what would be the range? Well, the way for me to get this is if I substitute the amount of shirts that I sold instead of S, right? So let's take a look. The cost of 1 shirt will equal, actually, let's start here. The cost of 0 shirts will equal 8 times the amount of shirts sold plus 15. Well, what do we know 8 times 0 to be? Anything times 0 is just 0, right? Plus 15. What's the cost if I sell 0 shirts? 15. Say it again.
That doesn't make sense because if no one walked in, then no one would be paying 15.
You wouldn't be paying 15. Remember, it's the cost of the shirt. $15 would be how much it costs to make the actual shirt. Well, remember, if you're opening a store, what's the expectation? Are you going to make shirts that same moment? Probably not. Imagine you had a whole flood of people. What do you want to do? You want to stock up on inventory, right? So the idea is that what would be the cost if nobody actually buys a shirt? $15, right? Right, because the price doesn't change, right? What do we keep adding to no matter how many people buy shirts? What's the number that we keep adding no matter how many people buy shirts? 15, right? You see it here. No matter how my shirts change, I keep adding $15. That's how much it costs for me to make a shirt. Okay? So then, okay, I make 1 shirt now. So the cost of 1 shirt is 8 times the 1 shirt to make plus $15. So this is 8 plus 15, which is equal to what? 23. So what am I doing? From 15 to 23, I only added 8. So can we continue that pattern? Yes, we can. What's the next one? 31. Okay, what's the next one? Okay, 39. What's the next one? 47. Next one. 55. Next one. 63. Next one. 71. Next one. 79. 0, 1, 2, 3, 4, 5, 6, 7, 8. What's my last one? 87. Higher level. If it cost me $15 for all those shirts, at what point did I turn a profit? At how many shirts did I need to sell in order to make a profit? Well, it cost me $15 to make, so I have to recoup those $15. $2. But I only made $8. But for 2 shirts, what do we say? The cost of 2 shirts is equal to 8 times 2 plus 15, which gives me 31. At that point, I finally turned a profit. I finally paid off the $15. I made $1 profit so far. And then after that, it's all profit, right? This is high level thoughts and application to the equation. But this is really what I need you to know. How to be able to write a domain and a range. Are we okay? That's really what I want you to do. I was just entertaining higher level thinking, right? Okay. Can I answer any questions about this? Okay, I need you to be able to write the information as well. So here we go. A teacher is restocking his pencil supply for the semester's tutoring group. All new students in the tutoring group receive 12 pencils. The teacher expects to have no more than 6 students attending the group. Here's the domain and range for the scenario, everybody. With 0 kids, well, I don't give any kids pencils. But the moment 1 kid walks in, I give them 12 pencils. Second kid comes in, 12 more pencils, so 24 total. Third kid, another 12, that's 36, and I continue going on and on. And just for you that can't see it, 0, 0. 1 kid comes in, I give 12 pencils. 2 kids come in, I give 24 pencils. And so on and so forth, right? So that is an example of how I would write a domain and range based on a scenario. So here's my next example. I want you to write the domain and range for this example. The neighborhood bakery makes and sells bagels every morning. The bagels are, and I misspelled that, I should say sold in sets of 6. And only the first 9 customers can purchase it. So I want you and your groups to write the domain and range for this scenario. I'm going to give you about 2 minutes for this, starting now. Sold, yes, I made a mistake. I should say sold. No, it's everybody gets a little one, half dozen. Everybody gets half a dozen. But only the first 9 customers. So if 0 customers walk in, but if 1 customer walks in, I give them 6, right? And then a second customer walks in, they also get 6. How many bagels have they had already? right? What's my independent? Right, so if nobody comes in, right? So then what's my dependent then? What's my independent? What depends on what? Or not, we're not talking about sales, we're talking about the amount of bagels, right? So then what's my independent? What's my All right, everybody, here we go. I think the hardest part here, everybody, was, well, what's my domain? What's my range? Right? Well, let's talk about it. What is my independent? What is my dependent? Do the amount of customers depend on how many bagels I give out? Question mark. That feels kind of icky to me. But let's flip it. Do the amount of bagels I give out depend on how many customers come in? Yeah, absolutely it does. That one feels a little bit better. So then which is my independent then? The people. The peoples. Peoples are my customers, right? Or my domain, right? And meaning that the bagels that I give out is my range. Let's take a look then. What are my possible values for the customers that are walking in? 0, nobody could walk in. What about the next one? Okay. 2, where am I heading to? 2, 3, 4, 5, 6, 7, 8, 9. In brackets, please. And now, what are my possible range outputs? If 0 people walk in, do I give out any bagels? No. What about if 1 customer walks in? They get it? 6 bagels. Cool. What about 2? All right, keep going. 8. Next. All right. Okay. Okay. Cool. Okay. 54. How do we feel about this? Are we feeling comfortable with it? Okay, one more example. Now let's put a graph into it. With that same logic and the same concept, could you write the domain and range for this graph? I'm going to give you and your groups 2 minutes. Take a look at the graph. I'm going to expand it a little bit more so we can see it up here. Go. Does the point start at 1? All right, everybody. Someone give me the first value for the domain. Where does my first point start? Yes, ma'am. What do you got? 0. Good. Someone else. Where do I going? Okay. Else. 2. Okay. 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 All right. Do I keep going? All right. That's my last point. Good. I'm just making sure you're awake. All right. Here we go. Range. There is no 5. Yeah, you lied to me. Wait. Thank you for the correction. Some of you lied to me. You just kept going with the motion. Is there a value for 5? No, look. There is, the points stop at 4, 25. So there is no value for it. Okay. Y'all are just liars. Just kidding, just kidding. Okay, so then let's talk about the range values then. Where do I start? If my first input is at 0, what's my output here? 5. Cool, okay. What about at the next one? 10, okay. 15, okay. 20, okay. 25. Ajá. Así me gusta. Okay. How do we feel about writing domain and range for interval points, right? It's pretty straightforward. Now let's step it up. I'm going to do the first problem with you because we are introducing a couple things. Everybody ready? Because this is what you're going to get lost if you're not paying attention, especially on your homework assignment. Are we ready? Whenever we're going to use what's called inequality notation. We talked about this at the beginning of class. So what does that mean? We're going to introduce some symbols. Okay? Here's what we're going to do. There is a skeleton that I want you to follow every time. When we write domain and range, let's start with domain. With domain, I would probably write this down. This is my skeleton. You should always write it like this. This is your basic starting skeleton. Not doing anything. This is what you're going to do. This is what allows me to write this. If you write it like this every time, you can write the lowest x value to the highest x value. So I go from low to high, just the same way that I read a book. This is your skeleton every single time that you write the domain. From there, certain attributes will change this a little bit. And we're going to talk about it. Here we go. Let's say how far to the left does this graph go? -2, right? But wait a minute though. What do you see about that -2? What do you notice about that end? It's not included. Why is it not included? What gives you that implication? The little circle, right? Here, I'm going to zoom in for those of you that are sight challenged, right? That open circle means that we do not include this, in our solution. We approach that value, but we will never equal that value. Okay, so what was my lowest again? What was my lowest? How far to the left does the domain go? To -2, okay. So then my skeleton. Now, how far to the right does the graph go? What's the farthest right value that you see? 5. But wait, that end looks different. What's different about it? It's filled in. So can we include that value into our solution? Can we equal that value? So here's what changes. Where did the 5 come from? Great question. Do you see this point here? That is the farthest x value. That's the farthest x value in our domain. What's the coordinate for this? 5, -7. But we're looking for the domain, right? Domain is what values? Our x values. How do we feel? Can I answer any questions? This is where you should ask questions if you do not understand. Estrella, what do you got? Emma, sorry, boof. Are we talking about the bars here? Okay, so great question. Do you see this hole right here, this open value, right? This open circle. This lets us know that we approach that value, but we never get to that value, right? So because we get to it, -2 is less than, meaning all of this portion, but we never actually get to 2, so we can't equal. The bar underneath lets us know that we equal that value, right? We talked about at the beginning of the class what all those inequalities meant, right? For those of you that are kind of forgetful, less than or equal to, greater than or equal to, less than, greater than, not equals, right? Now going back to this, because it's an open circle, we approach the value, but we never get to it, so we can never equal that value. That's why there is nothing here. It's just the less than symbol, okay? Does that answer your question, Emma? Cool, cool. Anyone else? Are we okay? Okay, let's talk about the range then. How far, again, same skeletons. For the range, it's the same thing. Lowest y value, highest y value. I want you to talk about it with your groups rather than me giving you the answer or all of us saying together. I'll give you 60 seconds. What is the range for this graph? And I'll zoom out so you can get the skeleton. Here, I'm going to write it also. Less than y less than. All right, everybody. Someone that hasn't interacted with me today. What's the range? You got this. Be brave. Be bold. The worst thing we could do is try again. Literally. Don't be afraid. Yes, ma'am. What do you got? What's my lowest y value of the graph? -7. Now, question for you. Do we include that as part of our solution here? Yes. So what do I need to include? The equals bar, right? The equals bar. Now, someone else, how high up does that graph go that hasn't interacted with me today? Be bold. Come on. Be confident. Yes, ma'am. What do you got? 9? Do we include that as part of our solution? Yes, we do. Now, for those of you questioning where we got those numbers, we got the first number from this coordinate point here, right? And where did we get the other number? This is the highest point of the graph, which we can read coordinates, right? That is 1, 9. So my lowest is -7 and my highest is 9. Cool. How do we feel about that? Cool. Can I answer any questions before we move on? I wanted to talk about other graphs, but we're kind of running a little bit out of time. I just want you to do this next example. Talk about the domain and range. I'm going to give you about 3 minutes with your group. So 3 minutes. Can you do number 2? What are you noticing about the graph? Some of the things that they put in the graph. So 3 minutes on the clock. Now,
it's also going to.
Everybody, real quick, before I let you continue, do we know what arrows do to a graph? What does an arrow tell us, indicate to us? It continues on how long? Forever, infinity, right? How many arrows do you see? Two, right? So think about that. Okay, it keeps going in those directions. How long is it going to go? Question mark. Go. Does it? Think about it. Can you approach and conclusively get the value of infinity? It is a never ending value. All right, everybody, let's talk about the domain. I want to see if I can guide some of you that potentially couldn't get it, but let's talk about it. Some of you are pretty bright. Let's talk about it. This graph is going to keep going how far? Forever. Even in that direction, even as I'm going to the left, it's going to keep going on forever. So my question to you is, with the skeleton here, less than x less than, how far to the left will this graph go? Forever. But forever in what direction? The positive or negative direction? Negative direction. So we're going to say this is heading in the negative infinity direction. That is the lowest value, meaning it's going all the way to the infinity, but in the negative direction. Now, here's the next important part. Is infinity a value we can include as the solution? Now, before you answer, think about it. Can you approach forever? Feels weird to say yes, right? Because think about this. The universe is still expanding as we speak. So getting to the edge of the universe is not an attainable goal ever, because it continues to expand no matter what. We will never achieve the edge of the universe. Think about that with infinity. We will never achieve infinity. There's always a bigger value. So that's why we will not include this. We will never equal infinity. So with that being said, how far to the right is this graph going to go? Positive infinity. We don't need to put a positive symbol. Infinity is perfectly well enough. That gives us the indication that it's positive. Here's the kicker. How far low is this graph going to go? Yes, infinity, but not in which direction? Where is it coming from? Look at the y. Yes, look at the y values. All the ones at the bottom are negative. So I'm coming from negative infinity. What is the highest point of the graph then? 9. Now my last question to you is, do we include 9 as part of our solution? Can we achieve the value of 9?
Yes.
You've done it. You've done it. How do we feel, everybody? One more slide for you, okay? We talked about this, and we're going to continue tomorrow very briefly. But we talked about function families, right? All of these equations are derived. For example, notice this. These two behave differently. All of these, they're all part of some type of family. We got them from somewhere, right? So here's my task to you. Using a graphing, what was it? Not calculator. Using a graphing tool, i.e. Desmos, right? We talked about these card sorts last Friday. We were analyzing. I want you to see if you can match the equations to each one of these graphs if possible. So you have 6 of them. That's all you have. Split it up into each one of you. That way you go a little bit faster, but everybody do some of the work. Type in the equations into Desmos and see what you get. Okay? I want to give you about 5 minutes for this. Okay? So 5 minutes, I want you to sort all of these graphs out, and then we're going to do something, okay? So 5 minutes, starting now. Look at the characteristics, everybody. What is the graph that you put on Desmos? What does it look like in comparison to the card sorts that we did? Right? And I've provided them for you on the OneNote as well in case you've never got a chance to glue them on your own notebooks.
Yeah.
Are you sure? That's how I do it in some things. Just like the other one. We need a little bit more time. I can only give you 2 minutes because I have to conclude this and you have to leave with something important.
Okay.
So, sure, that works. All right, everybody, here we go. The first one, which one of your graphs did the first one look like? Someone raise your hand and tell me. Right, what do you got? Graph F. Do we concur, everybody?
Yes.
Graph F, I like it, I like it. Someone else, what about the next one? 1/2 times to the x power. What does it look like? Graph K. Did anybody else get something different? Let's look at it. This one's crossing the y-axis somewhere here, right? Yeah, y is equal to parentheses 1 divided by 2. Oops. To the x. Wait a minute. This one's crossing it more or less right here. Is that how graph K looks like? Did I type that in right? Nope, I like it. Are we okay with graph K, everybody? Okay. What about the next one? Someone raise your hand and tell me. What does the other one look like? Graph C. It looks like it. All we did was -5, and we ended up somewhere here. What does graph C look like? Yep, I like it. This is graph C. Okay, what about the next one? What does the other one look like? Yes. Graph which one? A. Did it have little individual dots though? When you graph that equation, did it end up with a bunch of individual dots? Ooh, it didn't. So which one of the other graphs could it potentially look like? Actually, it does. I'm sorry, that's my fault. Graph A. What about the next one? What does the other one look like? Which one? G. And the last one, which one did that one look like? J. Graph J. Cool. Now, with our newfound knowledge, real quick, graph A is an example of what? A linear or exponential function? Linear. How do you know? Because it looks like a line. What about graph K? Exponential. Because it does something like this. It has a curve. What about C? Okay. What about graph A? Linear. What about G? Exponential. And what about J? Linear. Very important that you can tell now the difference between an exponential and a linear, because we're going to use this tomorrow as we start the last part of the lesson. Okay? Everybody, there is a Delta Math assignment due on Sunday, 9 p.m. It's really about domain and range. So work on it. All right, let's get to it.